Good day, grade 8. Our topic for today is all about axiomatic system. In axiomatic system, we have defined terms and undefined terms. The time we started to learn mathematics, we also started to learn its vocabulary. We have learned about definition of terms such as integer, quadrilaterals, and polygons. The reason that we need defined terms are: first one, we need to be precise and concise in what we say or write. Next, we need to understand each other and make sure that we mean the same thing when we say or write a particular word. A definition has two main parts, or the definition of defined terms. The first one is the term to be defined, and the second one is the explanation of the term. Why is there a need of undefined terms? So undefined terms are terms that do not require a definition, as these terms are used as a base to define other terms. They serve as a building blocks of other mathematical terms, such as definitions, axioms, and theorem. Okay? How do we know the meaning of term if we do not define it? By describing some of its characteristics, we may be able to have a good idea of its meaning, right? So using defined and undefined terms, we can analyze, or we're able to have a good idea of the meaning of terms, especially the terms that are not familiar to us. So like what I've said a while back, we use undefined terms such as definition, axioms, and theorems. The first one is postulates. Postulates are also known as axioms. These are the statements which are assumed to be true without proof. Thus, an axiom is a mathematical statement that is believed to be clearly true that is need not to prove. In general, we use postulate in geometry and axiom in other sections of mathematics. These statements are beginning assumption from which logical consequences follow. So again, postulate is also known as axioms, and postulate assumed to be true without proof. We have axiom for real numbers. These are some axioms often used in algebra and geometry. So the first axiom is commutative axiom. We usually encounter commutative axiom in addition and multiplication. Okay. Example, A plus B. In addition, we have A plus B is equal to B plus A. As you can see, A and B just change their position or exchange their position, but the answer is still the same. Also in multiplication, A multiplied by B is equal to B multiplied by A. Example, 1 plus 2 is also equal to 2 plus 1, since 1 plus 2 is 3 and 2 plus 1 is also 3. In multiplication, 1 times 2 is 2 and 2 times 1 is also equal to 3. So next axiom is associative axiom, also in addition and multiplication. So here we have three terms, which is A, B, C. In addition, we have A plus B, or the sum of A plus B plus C is equal to A plus the sum of B and C. In multiplication, the product of A and B multiplied by C is equal to A multiplied by the product of B and C. Let's try an example using numbers. Okay, in addition, we have 4 plus 5, or the sum of 4 plus 5 plus 6 is equal to 4 plus the sum of 5 plus, or 5 and 6. So 4 plus 5 is 9. 4 plus 5, we have 9. Then copy plus 6. So we have plus 6. Next, 5 plus 6, we have 11. Then copy 4 plus. So we have 9 plus 6 is equal to 4 plus 11. Let's check. 9 plus 6 is 15. Yes. 4 plus 11 is also 15. So therefore, this example is a associative axiom. Let's try in multiplication. So we have the product of 4 and 5 multiplied by 6 is equal to 4 multiplied by the product of 5 and 6. Let's check. 4 times 5 is 20, and 5 times 6 is 30. Next, 20 multiplied by 6 is equal to 120. Yes. And 4 multiplied by 30 is also equal to 120. So 120 is equal to 120. So therefore, it is also a associative action. So next, distributive action. So like for example, A, open parenthesis, B plus C, close parenthesis, or A multiplied by the sum of B plus C. You're just going to distribute A to B and A to C. So A multiplied by B, we have AB. Then copy the operation. A multiplied by C, we have AC. So let's try in numbers. So distribute 2 to 3 and 2 to 4. So 2 times 3 is 6 plus 2 times 4, we have 8, and 6 plus 8 is equal to 14. Therefore, if we distribute 2 from the sum of 3 and 4, the answer is 14. Next is the reflexive axiom. So A is equal to A is an example of reflexive axiom. Another one, we have 2 is equal to 2, 100 is equal to 100, and 18 is equal to 18. So next, we have symmetric axiom. Like for example, we have A is equal to B, then B is equal to A. If A is equal to B, then B is equal to A. Example, if 2 times 1 is equal to 1 times 2, then 1 times 2 is equal to 2 times 1. So for the next pre-recorded, we're going to study about the transitive, addition, multiplication, existence of additive inverse, existence of multiplicative inverse, existence of additive identity, existence of multiplicative identity. There are some of axioms often used in algebra and geometry. And that's the end of our discussion. Let's call it a day. Thank you for listening. Goodbye, grade 8.